Hello everybody, and we're going to continue section 16C on stationary points, and we're going to use what we've learned so far to start drawing a rough sketch of a function. So for this function below, we're only going to do the example on the left. We're going to find and classify the stationary points and sketch the function as much as we can. So remember, our first step is always to take the derivative, set it equal to 0, and solve for x. Our derivative here is 4x cubed minus 4x. I'm going to factor it, and I notice there's a difference of squares, so I'm going to factor that. When I set it equal to 0, I can see that either x must be 0, -1, or 1 to make this entire function equal to 0. So now I'm going to draw my sign diagram. And here I have that modified sign diagram again. So remember, I kind of turned it into a table. I have my number line along the top with my endpoints, -infinity and infinity. I have my my critical numbers here, also called turning points. So I'm going to put in 0, -1, and 1. And then I'm going to choose my test values. I'm going to pick a number between -1 and -infinity. I chose -2. If I plug that into my derivative, then I have a negative times a negative times a negative, which overall gives me a negative result and indicates, if my derivative is negative, that my function is decreasing. I'm going to pick a value between -1 and 0, in this case, -1/2. When I plug that into my three factors here, I'm going to get a negative, I'm going to get a positive, and I'm going to get a negative. So when I multiply negative times negative, I get a positive result. A positive derivative indicates that my function is increasing. If I pick a number between 0 and 1, like 1/2, I get positive, positive, and negative. Multiplying those together, I get a negative derivative, and negative derivative indicates my function is decreasing. Last, if I choose a number larger than 1, say 2, I have a positive, positive, and positive factor. 3 positive factors make a positive derivative, and that indicates that my function is increasing. Now that I know the shape of my function there, I can identify that if I've gone from decreasing to increasing, this must be a local minimum. If I've gone from increasing to decreasing, this must be a local max. And if I've gone from decreasing to increasing, this must be a local min. Drawing these little arrows helps me kind of visually see that. Now, if I'm going to make the graph, I need to know not just the x values, but also the y values that go with those. So I'm going to plug in -1, 0, and 1 into my original function. Remember that is this function up here, not the derivative. And I'm going to get 3 points, -1, -9, 0, -8, and 1, -9. And I look at the y values, I can see that this is the lowest that y gets. So they must both be global minimums. And this is the highest that y gets. So it must be maximum. Then I'm going to sketch my function roughly. So in my graph, I'm going to include the important x values, -1 and 1 and 0, and important y values, -9 and -8. I know I have a point at -1, -9, at 1, -9, and 0, -8. And in red, you can see kind of where I started my diagram. I know at this point it's a local min, so I kind of drew it like a very small valley. Same thing at this point. At 0, -8, I knew it was a max, so I drew it kind of like a hill, and I used those dotted lines to kind of join the shape together. We will draw diagrams that are a little more fancy than this, but we're building our knowledge over the next couple of days. Thank you.